Hi, I'm Wolf Dobson.
I'm Dan Galpin.
And I'm Bruno Oliveira.
So, money. True, there are many people who make games just for fun, but of course to many developers, making money from games is a crucial part of their business.
But they still got to have some fun, right?
Well, of course. So one of the questions we often get from developers is, how do I make money on Android games? I mean, if you're a developer, you probably wish there was an easy command to do that. But the truth is, it's not that simple.
Same thing with many other questions we get, like how do I get discovered? How do I get featured? How do I get that 5-star rating? How do I get rid of those pesky bad reviews? How do I make users play my game? And how do I actually make them buy stuff? It's a whole bunch of questions.
Sometimes these questions miss a fundamental point, and that point is that at the center of everything there's a user. We like users. They are fascinating, baffling creatures.
So instead of actually trying to answer those questions up there, we'll focus on what's really important, and it's that guy. Successful games are the ones that have many users, and where those users are happy. If you do that, the odds that you'll make tons of money, or even be featured on Google Play, goes up a lot.
Which is why we're going to focus on driving game installs and making a great user experience, along with the mechanics of actually collecting money from your players. So let's talk about sign in with Google. One thing you can do to grow your game is to use social features. We did a user survey recently and found that users overwhelmingly trusted Google to sign in across the web. This is because users trust Google not to spam their stream. You can share only what you want to share to the right people. Last year, we added APIs to enable users to log in with their Google Plus identity, and this year we added access to the social graph. So, quick update from Google Plus. 500 million users makes Google Plus one of the fastest growing networks in social history. Social networks in history. We've grown from just 150 million users between last June and last December. More than half of our users are mobile. We have 135 million active monthly users in the stream, and they spend about 12 minutes there daily. That's a lot of people. That's a lot of people who can be playing your game. If you think about it, Google Plus is truly at the heart of our efforts to create a simpler and more intuitive experience for all our users. It's our social spine that binds all of Google's products together. We have 120 Google Plus integrations to date that makes the user experience better on Google. When you see your friends' recommendations in Google Play, you don't think about that as Google Plus, but it comes from that infrastructure. We're seeing a positive impact across all our products. But what does sign-in do for developers? Well, first and foremost, it will help drive Android installs. There's a huge cliff getting users to install your app before they can play it, and we can help with that. I'll show how in a minute. Secondly is getting user growth through targeted social sharing. Google Plus allows you to share the right information with the right people, so that means gamers sharing information with gamers. You also have access to Google Plus profiles and social graph, which will give you a lot of information about your users. And finally, users obviously trust Google as a login provider. So what does this look like in a game? Here's my game, Nostalgic Racer, with Google Plus sign-in, and it's got a Google Plus login button. You can fit it into your interface any way you want. If you click on that, I get a Google-provided permissions dialog. There are two halves to it. The first indicates that I'm sharing my social graph with this app. From this dialog, you can even edit which subset of the graph you wanted to see. I might not want to share friends and family with this app, but I want to share all my gamer friends. Second half controls who might see that I'm playing this game. So if you want your high school friends to see that you're playing, but not your mom, you can make that happen. So after I click OK, I'm back to the game, and you can see that I'm completely logged in. Well, technically Bruno is completely logged in. If your users have signed into Google Plus on their phone, and this is very, very likely, using G Plus sign-in gets them signed in with one dialog very efficiently, with as little as 2 clicks if they like the default settings. So you, the game developer, now have access to their profile information, and you have a better idea of who's playing your game, and you can see their social graph, so you can see if they have friends who also play this game, or friends who might want to play this game. Now, let's say I play this game a whole lot and get an awesome time on one of the tracks on Nostalgic Racer. I want to post about it, and I want to make an interactive post about this track in particular. So let's see an interactive post. Here's one that I'm doing to Todd and Bruno. I've mentioned them by name, and I'm giving them a button to click to challenge me on 8-Bit Speedway. The two big things here. First, with the social graph data available, you can see which of my friends are playing Nostalgic Racer and pre-filled the dialog with their names. And secondly, by mentioning Todd and Bruno by name, they're really going to see this. Since I mentioned them explicitly, depending on their settings, they're going to see a notification on their G Plus stream, their email, the web, even a notification on their phone. It's a really high visibility share. So here's the post in the stream. You've got a challenge button, and people will come to play. On the web, if you click on the challenge button, it might take you to a website, your developer website, that'll show them how to install the game. On your phone, if you click on this link, you will go straight to the app itself. There are dozens of actions you can choose. Challenges is one of them. That button can go to the exact level in your game or provide some kind of help in a social game, anything you want. And this is huge. If you click on one of these links but you haven't installed the Android app, it will take you directly to the Play Store. That's awesome. That's a great way to drive installs. There's tons more on with Google+. We have over-the-air installs off your website. We have analytics. We have +1 button sharing. And we even have the Hangouts API for the web. So check it out on developers.google.com/plus. So sign in with Google+ can help bring audience and installs to your game, but your game has to be awesome for those players to have fun. Dan's going to talk about that.
My name is Dan, and I'm an Android gamer. Really. One of the great things that happened between last year at GDC and this year is that we published quality guidelines. To get to these quality guidelines, go to developer.android.com, click Distribute, and click App Quality. So here they are, Core App Quality Guidelines. There's a lot of stuff here that games often get wrong. We've been telling game developers for years to make sure their game navigates the Android way, with the back button being used to close their game. And we're gratified that users seem to agree. Bad back button support leads to bad reviews. Remember that this also applies to the volume buttons. Let the system handle them and show the default volume controls. One thing that our featuring QA team cares lots about is making sure that your game doesn't have a vestigial menu key. To remove it, target the latest SDK that you can test on, which of course should be 17. Targeting the most recent SDK version also turns off compatibility hacks that can impact game performance, so it's a good thing. Don't spam your users with notifications. Also, offer your users precise control over which notifications they are shown and when. You'll not only get better ratings, but you'll also encourage users with newer devices to not use the Android method of blocking all notifications. Don't use permissions you don't need. It's really unlikely that you'll need to get access to sensitive user data. From last year, here's stuff not to require, really. Feel free to pause and look more closely at this list. Don't consider this an exhaustive list. And receiving SMS is particularly bad. But using any of these permissions will make it difficult to get a game featured. We've also talked quite a bit about audio. Because no one likes random audio coming from their pants, especially your boss. Do time-consuming tasks in the background. Develop with strict mode enabled. Make sure that you don't get red flashes. Our testers will do it. Also, make sure that you support graphics for lots of form factors. It turns out that our quality team mostly has access to our Nexus devices. And if your game can work well with reasonable text sizes and touch targets on all of our Nexus devices, there's a good chance the game will work well on other devices. We also test on some other extremely popular and problematic devices. If your text isn't legible, or if the game requires smaller fingers, we have a problem. And of course, if you want to get featured, you better have a great feature graphic. Remember that many users will see your graphic on a phone. Phones are small, and the same 1024 x 500 bitmap that you see on the web Google Play Store is scaled down by Google Play to fit the smaller form factor of a phone. You'll need to have large text with excellent contrast if it will be readable. This title is legible, but on the device this subtitle is pretty much gone, and since I can't necessarily recognize that stylized ball as a soccer ball, on the device I might miss the reference to the game I love. But the best part about our Core App Quality Guidelines is they come with tests you can hand your QA team. So remember, to find out more about this, go to developer.android.com and under the Distribute tab, select App Quality. We've also talked about game controllers in the past. We've added support for standard HID game controllers in Honeycomb, and it's been gratifying to see so many games having some form of limited support for them. So one of my favorite games is Nostalgic Racer, and I was really excited to see that they have support for Nostalgic Controller. I spent lots for my Nostalgic Controller, so I'm the kind of gamer that sees the cost of your game as being incremental. And then I find that the menus don't navigate. There isn't a good set of default controls, and I can't use Nostalgic Controller with the game when my Nexus 10 is connected to my TV. So make gamers like me happy. Ship games that really support controllers, in menus and in the game. If you're going to have elaborate configuration screens, great, but also have great defaults. Almost every controller will work well in menus with these settings. And if your game only needs digital controls or buttons, this will be a great set of defaults. One thing to note is that I suggest supporting both D-pad center and A. And the reason for this is that, well, most HID controllers will have these buttons, and we do a great job of mapping these to reasonable defaults for D-pad, D-pad center, but for some reason we decided to map both A and B to the back button. And this doesn't really make sense to most users, as they are typically used to having the A button perform an affirmative action. So make sure to actually map the button that way within your UI. Here's some other buttons you might want to consider, but you shouldn't rely on these buttons being there. Some more buttons the standard controllers will have. One other note, you get generic motion events for analog joysticks. You also get them from D-pads that are set up as hat switches, which is very common. A single motion event, however, can have both a hat switch and analog motion. And if you handle the analog event, you must handle the hat switch event as well if you wish to use the D-pad in your game. Because otherwise, the system will think you've handled the analog event and you won't get the generated D-pad event. So here are some common axes that controllers will have.
So, in-app billing. In-app billing is actually pretty cool. Every time we talk about in-app billing to someone, we sort of expect them to go something like this. But then, to our surprise, in previous versions of the API, some people went more like that. We didn't really understand why that happened, because in-app billing is actually pretty simple. I mean, you just do that and the item's purchased, right? It's no problem.
Wait, don't you have to do more than that?
More than that? Okay, I'm actually oversimplifying just a little bit. You actually have to have the code that handles the purchase state changes. But then it's still not that complicated.
But what if the app is sleeping?
Oh, okay. If the app is sleeping when that happens, then you should probably just add a broadcast receiver just to make sure you don't miss that message. But that's still pretty simple.
But broadcast receivers can't run for a long time. So what do you have to do? Lots of database work or networking.
That's true. Real applications have to do that, right? So you should probably just add a very simple and straightforward service, something kind of like that. And that's going to take care of handling that for you. As you can see, the code is very straightforward and simple to understand.
But what if you're using managed items? Don't you need to make sure that you persist those? Because you can't call Google Play very often to check for them.
That's true. So you should, I mean, everybody loves databases, right? So I think you can just add some database code to your app just to make sure that you store the purchases. And then you don't have to make the calls all the time. Oh, and they should also obfuscate that some way, because otherwise users can just hack into that and alter. So but it's still pretty simple, right? You don't believe me. So why does it get so complicated? Let's start with the simplest possible case. So the user just wants to buy something, and they buy something, and it gets delivered to the app. So far, no problem, right?
Thanks, bro.
Exactly. So not a problem so far. But suppose that instead the app is sleeping. What happens in that case? In that case, if the app is not running, sleeping, or something else, a different guy has to pick up the package. That guy is the broadcast receiver. And then that guy has to take care of delivering the package to the app when it wakes up.
Thanks, bro.
Exactly. And that's when problems can happen, because suppose that guy is not as reliable as you think, and he drops the package or loses the package. So in V2, there are actually many components that have to work together to ensure that the user's purchase is handled correctly. And it can get a little complicated. In comparison, here is what the version 3 diagram looks like. No, actually, let's use more of the slide for that. That's not going to fit. Let's use a full slide. Yeah, that's better. So the diagram for V3 is very simple, but it has 7 subcomponents, and we're going to spend the next several minutes discussing each of the components, subcomponents, and also the subcomponents.
And they're pastels.
Exactly. Actually, just kidding. This is the diagram for in-app billing V3. It's much simpler, right? So the main improvement in V3 is that API calls are now synchronous. So this means that your application can get a response right away. And it's much more straightforward to think about too. For instance, if you want to buy something like 50 gold coins, all you have to do is make a request that looks something like buy 50 gold coins. And guess what? If the purchase is OK, the API is going to return something that's pretty simple, like say, OK. And if you're used to V2, you probably remember that listing the items that are owned by a particular user is a very expensive operation, so you couldn't call it all the time. So you had to do that very sparingly. So your whole code had to be structured around that limitation. In contrast, in V3, Google Play actually implements a client-side cache and takes care of keeping that in sync with the server for you. This means that calling restore purchases is actually very cheap, and you can do that as often as you need. For example, you could just do that every time the application starts, so you know what items the user owns. So I probably sound like I'm trying to sell you something. So if you're a developer, then over the years, you've probably grown a healthy mistrust of people that don't show you any code. So let's stop with the sales and move on to something that's entirely different. All right, so let's talk about selling stuff. Before you can make any v3 API calls, you have to check that it's actually supported. You can do that by using the isBuilding-supported API call. The good news is that the in-app building version 3 API is supported on all devices running Froyo and above, and a recent version of the Play Store, and that corresponds to over 90% of the currently active devices. Now, how do you get a list of the items that the user owns? You just call getPurchases. Remember that this call is actually pretty cheap, and also notice that you get the results right away without having to implement any funny callbacks. Now, this is the moment your application has been waiting for. It's that profound, unique, magical moment of modern technology where the user realizes that your virtual item is so cool and so awesome that they're actually willing to give you real money for it. Most important of all, at that moment, you have the user's trust. So imagine what happens if you take the user's money and then lose the purchase. That's a pretty bad experience, right? So again, they've paid for something and they didn't get it. The least you can expect after that is a bad review, and you're probably going to have to refund that money. And the user is probably not going to be a user anymore, so that's something to be avoided. So this is why version 3 actually makes it easier not to lose purchases by making all items managed, which means Google Play keeps track of those purchases for you. So how do you launch this purchase flow? You can call getByIntent to get an intent that's going to launch the purchase window, and then you launch that intent using start intent sender for result. The results of the purchase are going to come back through your activities on activity result callback. At that point, you get the purchase response code, the purchase data, and the signature. And that's pretty much all there is for a simple app. So on startup, you call getPurchase to see what the user owns. When the user wants to purchase something, you call getByIntent and then launch that intent. And on your activities on activity result callback, you handle that purchase. And notice that it's actually pretty hard to lose a purchase this way. You actually have to make an effort to lose a purchase, because even if your application crashed right after you started the purchase flow and you never got the purchase result, it's all right, because next time your application executes, you're going to call getPurchases, and you're going to realize that the user has bought that item, so that purchase is not lost. Now let's talk about consumption. So consumable items are a new feature in v3. So to understand how it works, let's do it like that. Somewhere inside Google Play, there's a box with my name on it. I know, I've seen it. And inside are all my virtual items. So what happens when Bruno buys cool item? When I buy cool item, an item called cool item appears inside that box. If you then ask Google Play, what items does Bruno own? It's going to return Bruno owns cool item. If I consume that item, what happens? The item goes away in flames, just like that. I've seen it happen. In that case, I don't own that item anymore. And if I ask Google Play, what items does Bruno own? It's going to return the empty set. So consuming an item just means that it's no longer there. So how do you do that in code? You just call the consume purchases method, and you just pass it the purchase token that you got from the getPurchases call. One question that naturally arises is, when should I consume something? That's actually up to you to decide how to use the consumption API. But we're going to talk about two of the most used methods. You can either consume the item when it's actually used, or you can consume it immediately when it's purchased. Both of them have advantages and disadvantages. To explain method one, I'm going to give a quick example. So that's me. Anyway, that's the stick figure me. And those are the items that I own in Google Play. Like everybody else, I walk around with a hit point bar on top of my head. And as you know, it's a pretty dangerous world out there for stick figure characters. So I'm probably thinking, before I venture out there battling bugs, I'm better off buying a potion. So I buy this potion, and then I own this potion, correct? And then I go out and venture into the wild world of programming. And in the course of my adventures, I battle several bugs, and I end up losing a whole bunch of hit points. Then I decide to use that potion. At that point, your application is going to consume the potion, and then give me a full hit point bar. So that's how it works. That's a perfectly good method, but it has a significant limitation. So it has to do with how Google Play actually thinks about things. So Google Play only really knows two numbers, 0 and 1. If your game actually requires that I should be able to buy more than one potion, then this method doesn't work for you. Because if it's a really dangerous world out there and I'm going to need more than one healing potion with me, then I can do that using this method. Because as soon as you try to buy a second potion, what's going to happen is that Google Play is going to notice that I already have a potion. So it's going to see there's a potion right there. Why are you asking for a second one? That makes no sense. Google Play can only count to one. So you need a better method if you're going to implement that. And that method is consumption, is immediate consumption. In this case, your application is responsible for managing the user's inventory. Notice my excellent rendering of a plastic bag there. So when I buy something, you immediately consume it, and then you put it into my plastic bag, or inventory, or wallet, or anything else in your application. And from that point on, you are the one responsible for managing that item. So if I buy a second one, that's all right with Google Play, because it doesn't know that I have another one. So I consume that one and add it to my inventory, and everything works. If you're using this method too, it's very important to also check on startup if there are any outstanding items that you need to consume. For example, suppose that your application crashed right before consuming an item. You purchased something and then you crashed. What happens is that next time you start up, you should check the user's inventory and make sure that there's nothing consumable there. If there is something consumable that should have been consumed, this is the time when you consume it and credit it to the user's inventory to make sure that they didn't lose that purchase. So summarizing, on startup you call get purchases. If you find a potion there, you consume it. When the user wants to purchase something, you call get by intent and then launch that by intent to get the purchase flow. On your activities, on activity result callback, if the purchase was successful, you try to consume it. When you get the result from the consumption, you add it to the inventory, if it was successful, of course. Now, let's move on to a very important subject, which is security. So, believe it or not, in the interwebs, there are some shady characters out there, shocking, I know, that may be trying to take your stuff without paying. I don't really know what the technical term is, but I'll say they're pirates, mostly because we spent a really long time drawing this character, and I had to use it somewhere. So every time you see a purchase in your application, you should ask yourself, is that purchase legitimate? And a pirate's job is going to be to try to convince you that it is. And your job is to detect that they are lying. No one can actually stop piracy altogether. I would be lying to you if I said as much. But you can actually make life pretty hard for pirates. So here are some defenses you can employ: developer payload, signature verification, and server-side validation. Let's talk about developer payload. Developer payload is actually something really simple. It's just a tag that gets attached to every purchase. And whenever you query for that purchase, it comes back with it. So you should use it to identify the owner of the purchase. And the reason why you want to identify the owner of the purchase is to prevent a replay attack. So how does that kind of attack work? Okay, so again, that's me, a stick figure again. Like everyone else, not only I have a hit point bar, but I also have an evil twin. So it's that guy over there. That guy, apart from having a goatee, isn't very honest. And last week he actually picked up my phone and did a database dump on the items I had, and then tried to replay them on his device, hoping to get items for free. So when Onurb, my evil twin, runs your application, you'll check what items he owns, and you'll see this purchase. Now, all you have to do is check the developer payload, and you'll know that it's a fake, because it says belong to Bruno, and it's Onurb that's trying to use it. And it's hard for Onurb to fake that developer payload, because every purchase is signed with a private key that only we have. So it's very difficult for him to alter that signature. So speaking about signatures, so what is signature verification? Well, every application has a private key and a public key. The private key is known only to Google, and the public key is known to you. Every time we send a purchase response, we sign that purchase with the private key, and then you can verify that signature with the public key. So this means that nobody else outside of Google can actually send you a purchase, a correctly signed purchase. So if you check that, you can be reasonably sure that the purchase is legitimate. Now, signature verification is not actually very difficult, but I mean, you can implement it just using the standard Java framework, but it comes with our sample. So if you're just basing your code on our sample, you don't even have to implement that. Even though signature verification is pretty cool, thinking that client-side security alone is enough would be a big mistake. Because regardless of how secure you make things, phones can be hacked. So you should definitely add server-side security to your application. On the server side, you should check the signature again, just in case the client has been compromised. A cool thing you can do in the server that you can't do on the client is to check order numbers, because since you're receiving every order from every user, you can check if a given order number is a duplicate from another order number that you actually delivered to someone else. And it's very important that you secure the handshake, because it's not going to do you any good if you have a perfectly good signature verification, order number verification method, and then the handshake is very insecure. So make sure that the handshake is also very secure. So just giving you a summary of the security methods that we presented. If you don't do anything, you're essentially a sitting duck, and you can be and anything can be used to exploit your application. If you do only client-side signature verification, you are protected against a man-in-the-middle attack. So it's going to be hard to replay purchases. If in addition to that you use the unique developer payload, then you're also going to be relatively protected against purchase replay attacks. If you add server-side verification to that, you're also going to be safe against a rarer form of attack, which is framework compromise. The actual combination of methods that's appropriate for your application is largely your decision. We just wanted to outline to you some of the security methods that are the most popular.
And one more thing. One of the things that you as game developers have been asking for ever since the launch of in-app billing in Google Play is the ability to get real-time pricing information so that you could actually display the actual price that Google Play will be charging your users. And it turns out that's one of the main things we've added in IBB3.
Imagine if that was even localized to the user's language.
And it is.
And it is.
So you can actually do quite a lot with that. So that's pretty much all we have on in-app billing and on game quality.
We hope you enjoyed.